Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integration, right? So in this class we'll solve this integral where we have 0 to infinity x raised to 4 divided by x cube plus a cube whole square, right? And here a is greater than 0, right? So we'll solve this integral by the application of beta and gamma functions, but this integral can also be solved by the method of residues, right? Or by contour integration, right? So but in this lecture we'll confine ourselves to the application of beta and gamma functions, right? So let us start. So let us first call this integral as I, right? Now see here first we'll make use of the method of substitution, and here we have the number a. So what we will do, we'll take x cube is equal to a cube t, right? So here we'll introduce a new variable t such that x cube is equal to a cube t, right? So x can be written as a cube t raised to the cube root of a cube t, that is 1 over 3, right? So x can now be written as a t raised to 1 over 3. So here 3 and 3 get cancelled, so we are left with only the exponent as 1, right? So x is equal to a t raised to 1 by 3. Now let us differentiate x with respect to t. So we have dx over dt is equal to a. Being a constant, we can keep a as such, and the derivative of t raised to 1 by 3 is 1 over 3, t raised to 1 over 3 minus 1, right? So we can write it as a over 3 t raised to 1 minus 3 over 3, that is a over 3 t raised to minus 2 by 3, right? So dx can now be written as a by 3 t raised to minus 2 by 3, and here we have dt, right? Okay, now let us change the limits. Here see x varies from 0 to infinity. So when x is 0, the value of t can be calculated from this expression. So t is also equal to 0. And when x is infinite, that is x tends to infinity, then t also tends to infinity, right? So now we can write this integral I in terms of t as 0 to infinity x raised to 4. So we have x is equal to a t raised to 1 by 3. So we have a t 1 over 3 raised to 4 divided by x cube. X cube is a cube t plus a cube whole square, and here for dx we can write a over 3 t raised to minus 2 by 3 dt, right? So now let us rearrange the terms. So we have I is equal to 0 to infinity. Here we have a raised to 4. Then we have t raised to 4 by 3. And here in the denominator, if we take a cube common, then we have a raised to 6 and t plus 1 whole square, right? And here we have a by 3 t raised to minus 2 by 3 and dt, right? Okay, so now we can simplify it further. Now see, here we have a raised to 4, a raised to 1. So 4 plus 1 is 5, and here we have a raised to 6. So these two terms get cancelled, and here we are left with only a, and in the numerator we have t raised to 4 by 3 minus 2 by 3, because the base are same, so exponents get added, and here we have 3 times a and t plus 1 whole square, and here we have dt, right? So now we can write this integral I as 1 over 3a. We have 0 to infinity, and t raised to 4 by 3 minus 2 by 3 is 2 by 3. And in the denominator, we have 1 plus t whole square, right? Okay, so now we have this integral. Now what we will do, we'll convert this integral into the beta integral or beta function, right? Now see, the beta function is defined as beta mn is equal to 0 to infinity, and we have x raised to m minus 1 divided by 1 plus x raised to m plus n dx, right? So now our aim is to express this integral like this, right? So what we will do here, see, here we have t raised to 2 by 3, and here we have x raised to m minus 1. Now see, here the variable is t, here the variable is x, and since indefinite integrals, it is a dummy variable and it is not going to make any difference. So we have m minus 1 is equal to 2 by 3, right? Comparing the exponents. And here 1 plus x raised to m plus n. So here we have 1 plus t raised to 2. So we have m plus n is equal to 2, right? So now we have two equations. So we can find the values of m. M is 2 by 3 plus 1. That is taking minus 1 to this side. We have 3 ones are 3 plus 2, 5 by 3, right? And n can be calculated as 2 minus m. So this is 2 minus 5 by 3. So 3 2s are 6, 6 minus 5, 1. So we have 1 by 3. So now we can write this integral I as 1 over 3a 0 to infinity t raised to 2 by 3, right? So 2 by 3 can be written as here m minus 1. So m is 5 by 3. So we have 5 by 3 minus 1, because 5 by 3 minus 1 is 2 by 3. Here we have dt, and in the denominator we have 1 plus t, 1 plus t square, right? And this square is equal to m plus n. M is 5 by 3 plus n is 1 by 3, right? So that 5 plus 1 is 6, 6 over 3 is 2, right? So we can also write the values of m and n directly. So now this integral is our beta integral or the beta function. So we have beta m comma n. M is 5 by 3 and n is 1 over 3, right? And now we know an important relation between a beta function and the gamma function. So beta mn is equal to gamma of m, gamma of n divided by gamma of m plus n, right? So here we have 1 over 3a, and we have gamma of 5 by 3, gamma of 1 over 3, and then we have gamma of 5 by 3 plus 1 over 3, right? So now we can simplify this expression. So I is now equal to 1 over 3a, and gamma of 5 by 3 can be written as 2 by 3 plus 1, right? And here we have gamma of 1 over 3 divided by a gamma of 2, right? Because 5 plus 1 is 6, 6 over 3 is 2, and here we have expressed 5 by 3 as 2 by 3 plus 1, because see, we know an important relation in gamma function, that is the gamma of n plus 1 is equal to n gamma of n, right? So this n is 2 by 3, right? So we can write gamma of 2 by 3 plus 1 as 2 by 3 times gamma of 2 by 3, right? So I is now equal to 1 over 3a. This is 2 by 3 times gamma of 2 by 3 and here we have gamma of 1 over 3 divided by gamma of 2, right? Now see, gamma of 2 is equal to 1, because we know that gamma n plus 1 is equal to n factorial. So n is 1 because 1 plus 1 is 2. So 1 factorial is equal to 1, right? So here we have 1. So now we have to simplify this expression. Now see, here we have this term, right? That is gamma of 2 by 3 and gamma of 1 by 3, right? Now see, gamma of 2 by 3 can be written as 1 minus 1 over 3, because 3 ones are 3 minus 1, 2 over 3, and here we have gamma of 1 over 3. Now if we take 1 by 3 as n, right? So this expression now reads as 1 minus n, and here we have gamma of n, and gamma of 1 minus n times gamma of n is equal to pi over sine n pi, right? So this is the famous Euler's reflection formula, right? So we have this term is now equal to pi over sine n pi. N is 1 over 3, so we have pi over 3, right? So this is pi divided by sine pi by 3. So sine 60 degrees is equal to square root of 3 over 2. So this is 2 pi over square root of 3. So now our integral I is equal to 1 over 3a, then we have 2 by 3, and now we have 2 pi over square root of 3, right? So taking the product here, so we have 4 pi, 2 to the 4, 4 pi over 3 3 is a 9 a root 3, right? So the value of this integral is equal to 4 pi divided by 9a times square root of 3. So now suppose we have to find the value of this integral, that is 0 to infinity x raised to 4 divided by x cube plus 1 whole square. So if we compare this integral with this one, then the value of a is 1, right? Because here we have a cube and here we have 1. So this one can be written as 1 cube. So the value of a is 1. So the value of this integral is given by 4 pi divided by 9 times a times square root of 3. So taking a is equal to 1, we have 1 times square root of 3. So this is 4 pi divided by 9 root 3. So this is the value of this integral. Hello viewers, in today's class we are going to discuss one important problem from integrals, right? And in this class we are going to discuss this integral which is 0 to infinity, and the integrand is 1 over x raised to 4 plus 1, and we can solve this integral by the method of contour integration, right? So we can also apply the method of residues to solve this integral, but here we'll make use of the concept of beta and gamma functions, right? So let us start. So let us first take this integral as I, right? So here what we will do, we'll take help of the method of substitution, and we'll take x raised to 4 equal to t, right? So here I will introduce a variable t such that x raised to 4 is equal to t, right? So x can be written as t raised to 1 by 4, and let us differentiate x with respect to t, right? So we have to find the derivative of t raised to 1 by 4 with respect to t, that is 1 over 4 t raised to 1 over 4 minus 1. So here we'll make use of the power rule for differentiation. So this is 1 over 4 t raised to 1 minus 4, that is minus 3 over 4, right? So now dx can be written as 1 over 4 t raised to minus 3 by 4, and here we have dt, right? Okay, now see here the limits of integration vary from 0 to infinity. So when x is 0, then obviously t is also equal to 0, and when x tends to infinity, then the value of t also go to infinity, right? So now we can write this integral in terms of t. So we can write I as 0 to infinity. Here we have t is equal to 0 to infinity, and here we have dx. For dx we can write 1 by 4 t raised to minus 3 by 4 dt, and in the denominator we have t plus 1, right? So let us rearrange the terms. So we can write 1 by 4 outside the integral. We have 0 to infinity. Here we have t raised to minus 3 by 4, and here we have 1 plus t, right? Okay, now see, here we have this integral. Now let us revisit the definition of beta function in terms of integral. So beta mn is defined by this integral, that is 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx, right? So now this integral is similar to this one, and here I will express this integral like this, right? So for this what we will do, see here we have 1 plus t raised to 1, right? And here we have t raised to minus 3 by 4. So let us compare these two integrals to get the values of m and n. So m minus 1 can be taken as minus 3 by 4. So m is minus 3 by 4 plus 1, that is minus 3 plus 4 over 4, that is 1 over 4, right? And m plus n may be taken as equal to 1, right? So m is already 1 over 4, so n is 1 minus m. So we have 1 minus 1 by 4, that is 4 minus 1 over 4, that is 1, that is 3 over 4, right? So the value of m is 1 by 4, the value of n is 3 by 4. So now we can represent this integral I uh, in terms of the beta function. So we have here 1 by 4. This is 1 by 4, 0 to infinity. And we have t raised to minus 3 by 4, right? So here t raised to minus 3 by 4 can be written as m minus 1. And m is 1 by 4. So we can write 1 by 4 minus 1, so that we can get this term x raised to m minus 1, right? And here we have dt, and 1 plus t raised to 1. So we have 1 plus t raised to 1. 1 is equal to m plus n. M is 1 by 4. N is 3 by 4, right? So this is 3 plus 1, 4. 4 over 4 is 1, and 1 by 4 minus 1 is minus 3 by 4. So again we'll get the same integral, except that we have expressed the integrand like this, right? So now I is equal to 1 by 4 beta of mn. M is 1 by 4, n is 3 by 4, right? So now we have to find the value of beta 1 by 4 comma 3 by 4, and we know the relation between beta function and gamma function, that is beta mn is equal to gamma of m, gamma of n divided by gamma of m plus n, right? So here we have 1 by 4, gamma of 1 by 4, gamma of 3 by 4 divided by gamma of 1 by 4 plus 3 by 4, right? So this is 1 by 4 and we have here gamma of 1 by 4. And now see, here we can write 3 by 4 as 1 minus 1 by 4, right? Why we are writing gamma 1 by 4, gamma 3 by 4 like this? Because now this term is similar to the term which appears in the Euler's reflection formula, right? So now we have here in the denominator gamma of 3 plus 1 4, 4 over 4 is 1, so gamma of 1. So now the Euler's reflection formula, it reads like this, that is gamma of n, gamma of 1 minus n is equal to pi over sine n pi, right? And now see, if you take this n as 1 by 4, then we have this term, that is gamma of 1 by 4, 1 minus 1 over 4. So taking n is equal to 1 by 4, in this term we have pi over sine pi by 4, right? So this is pi, sine pi by 4 is 1 over root 2, and this is sine 45 degrees, so this is pi root 2, right? So now this term is equal to pi root 2, right? So we have I is equal to 1 over 4, and here we have pi root 2, and gamma of 1 is equal to 1, right? Because we know that gamma of 1 is equal to 1, right? So the value of this integral I is given by pi root 2 divided by 4, right? So if we rationalize the numerator and denominator by square root of 2, then we can also express it like this. We have pi root 2 over 4 multiplied root 2 over root 2. So this is root 2 times root 2 is 2. So we have 2 pi over 4 root 2. So this is 2 to the 4. So we have pi over 2 root 2, right? So viewers, the value of this integral is equal to pi over 2 times root 2.